Like I've said a zillion times on my videos, knife making is not a spectator sport, so it's kind of going to be a little boring. There's I can think of 4 different ways to weld a stack of steel. The whole idea, like a lot of my knife making buddies know, is to get that weld, you have to eliminate the creating of iron oxide between the layers of steel. I'm going to do something that is called it's a kerosene weld. My forge, right now my forge is up to 2,000. About 2,050 degrees. Good welding temperature. I wish it was at 2,100. It'll get there, but what a kerosene weld does, I've got a stack. I'm making a solid billet of 80 CRV to forge some integrals from. I've got some 3/8 thick by must be 1 3/4, 3/8 thick, 1 3/4, 80 CRV. I cut a stack of them, surface ground them, good surfaces, surface ground all the pieces, and stick it in a container of kerosene so there's kerosene over all the surfaces, and when that kerosene ignites, it literally leaves a layer of soot, right? Black soot between the layers, which is pure carbon. So that is going to be our barrier between the steel and the superheated oxygen in the forge. So I'm just about to stick that in there. I'm going to stop this recording for just a minute. I want a little more heat in my forge. I want to see 2,100. I'm not quite there yet. But anyway, that's what I'm going to do is a kerosene weld on a stack of 3/8 80 CRV to do some integrals from. So I'm going to shut that off until it gets a little bit hotter. Here we go again. Okay, so right now I've got 2135 on my forge temp. I want it good and hot because it's a lot of steel. It's only a 4-inch billet, but about 3 inches tall, and it's 3/8 thick and 1 3/4 wide. So I'll get a few knives. Out of that. But just heard a weird noise. I don't even know what that was. Anyway, I'm gonna stick it in there, and it's gonna be covered with kerosene, so there's gonna be a big blast of flame, right? So here we go. And as a matter of fact, I bet we're hotter. My temperature probe was pulled out of the forge. I wondered why it had cooled off. Yeah, it's going way up. We're good and hot right now. So here goes a bunch of flame. Not too bad. But it's a lot of kerosene burning there. Will get burned now. The other part of this is that once that piece of steel goes in, once that block of that billet goes in there, you don't take that back out until it's at welding temp. So that thing's going to sit there for, I don't know, 10-15 minutes, And I literally want to look in that forge and not even be able to see it because it's the same color as the inside of the forge. So now it's what I talked about, knife making not being a spectator sport. It's a whole bunch of just sitting and watching things. So I gotta let that heat up. Okay, we're back. And anyway, I'm hoping y'all can hear my dialogue on this. 15 minutes. The billet has just been in the forge 15 minutes. Now I have a pretty sensitive temperature probe in my forge, and whenever I stick something in the forge, I mean, it's sensitive enough. I'm sure you can understand. Put something in the forge, it absorbs the heat, and this thing will show the temperature will drop. And anyway, just to jump ahead, 2197, 2198, 2199, 2,200 degrees. And the temperature's rising, not dropping, which means, and as I'm looking in here, the color's almost yellow, and the billet is exactly the same color as the lining of the forge. So, and it's been running now 16 minutes. I'm going to stop my stopwatch. And everywhere on that billet, there's no scale. Anyway, I'm going to squeeze it, and it's going to be a weld. Toward the internal zones of that billet, it's still screaming hot, but those dies suck heat out of the outer portion of the billet. So what I'm going to do, I'm just going to give this a couple minutes to make sure it's back up Guten hot. I'm going to give it another squeeze. Then I might reduce its thickness just a little bit. I don't really know. Probably I'll give it another good squeeze, and then I'm going to turn it on edge and gently squeeze it down on the bias against the layers. Make sure it got a weld, right? I mean, if it's not welded, that's where we're going to get separation. And I'm just going to be gentle with it. I'm going to go outside. I've got a steel sawhorse outside, and I'll put that thing up on edge and grind away those edges, and look for any kind of a line that looks like a joint, a seam between two pieces. If I can see a line, it's not welded. So I will just grind until there are no lines on the edges, and that is literally, for all intents and purposes, one solid block of 80 CRB. So let this thing come back up to temp, and we pretty much are. So I'm just going to give it another squeeze here. Block of 52-100. see, I can just barely see some lines. That's a little scale. I'm gonna go out and grind this thing smooth and make sure I got a solid block of steel. Back. Without doing a whole lot of show and tell, I took that billet out on my I-beam sawhorse, locked it in the vise, ground the edges off until anything was gone that didn't look like a weld, and for all of my future purposes, I have a solid block of 80 CRV. Now there's going to be that little area on every weld. Remember I said it's just basically pure carbon. Carbon at welding temperature wants to do kind of like water, or you know, if you dissolve a bunch of Nestle's Quick, remember the old spoon dried Nestle's Quick you put in a glass of milk? It doesn't all just go to one spot. It dissolves, and what it does is it dissolves equally throughout that glass of milk. The carbon seeks equality. No diversity, no inclusion, but it seeks to be equally distributed throughout the billet. So as I'm reducing this steel, that carbon in that concentrated area is going to equalize into the areas around it. And when I get done with one of these knives, and you can look at it, it's literally a solid block of steel. So I'm going to start drawing it out a little bit. Take my big flat dies out, and I put in some flat dies. Flat drawing dies. I guess they're flat drawing dies as opposed to round drawing dies. And then once I make sure I've got a good bill of steel. It's Father's Day, by the way. Happy Father's Day to all the fathers out there. That's a pleasure that has escaped me my entire life. You know, it takes two, right? I've been one most of my life. But anyway, that's it. Happy Father's Day to all the fathers out there, and enjoy it. I'm going to finish this and go get some breakfast.